Good morning, everyone. Today we are going to start the unit number 4, that is IoT protocols and security. In the last session, we have finished with the unit number 3, and I already provided you the assignment number 3 for this uh, unit number 3. So, from the unit number 4, we are starting with the protocol standardization for IoT efforts. Okay, so first we are going to see the protocol standardization for or the standardization IoT standardization efforts. So in the based on the 4 pillars of IoT in the last unit, we have concluded that IoT standardization is needed for data representation and protocols. So now we have to focus on the standardization of IoT. So before that, we will see that IoT architecture. Okay, so the IoT, that is Internet of Things architecture. It is targeting a universal architecture. This architecture is universal for all the IoT sectors. So near about 17 European organizations from 9 countries are part of that IoT architecture. So that participants, or we can say this organization, summarize the current status of that IoT standardization as like here you can see the current IoT standardization for the IoT architecture. So that architecture is a fragmented architecture. Okay, so there is no universal approach to implement IoT uh, in the proposed system. Okay, so many island solutions that exist, that like RFID is there, sensors are there, then later cross sectors reuse of technology and exchange of knowledge. So there are some limitations in the previous standardization of this IoT architecture. So now in the current, what should be that what we can say that in the current IoT standardization, there are some problems are there. So we have to that what we are going to do with the or how we are going to overcome that problems that previously that standardization is having. Okay, so so that we are going to propose a solution for the IoT architecture standardization. Like we are going to create a architectural foundation for IoT that will be operable with the future internet. That means to create an architectural foundation for IoT, we have to create architectural foundation for the IoT, so that will be interoperable with the future internet. Okay, so then we have to use this existing technologies. We have to use existing technologies instead of creating new ones. If we are going to improve something, that instead of creating new ones, we have to use existing technologies for that. Then the we have to prove the usability of application with the help of use cases. Okay, so we are going to use the use cases. So we have to use or we have to proving the usability of applications using the use cases. Then we have to create or we are going to create the interdisciplinary solution which targets more deployment aspects that will generate this strong stakeholders. Okay, so we have to establish a strong stakeholders group to remove the barriers, and we have to accept on that we have to accept that IoT on the wide scale. Okay, then we are going to combine the various IoT technologies into a single entity. So by applying all the solutions, we are having a strong IoT standardization. Okay. So for that, by keeping these points, there are some efforts, or we have to make an efforts regarding that standardization of IoT. Like we are having the work package framework, and we are having the Internet Protocol for smart objects, that is IPSO and WP framework. Okay, for this standardization. Here, before that, we have discussed about that we have to group. Here we can see that we have to combine the various IoT technologies. We have to combine the various IoT technologies to groups. Okay, so that groups like a work package framework, that is WPF, then International Telecommunication Union, that is ITU, ITUT, that is Telecommunication Standardization Sector, and then Internet Protocol for Smart Objects, that is IPSO. Okay, that IPSO aims to form an open group of companies to market and educate about how to use the IP for IoT smart objects. Okay, so now first we will see the work package framework. So work package framework defines the overall gross view of an IoT system with respect to all the stakeholders. Here you can see that work package framework, that is WPF, divides the group divides the implementation standards for IoT into the hierarchical groups. Okay, so you can see in this diagram there are different groups are there, like WP1, WP2, P3, likewise up to WP9. Okay, so this the work package framework consists of some service providers, developers, investors, and users are there. Okay, so as shown in this figure, you can see that this work package framework gives implementation standards for developers using architectural reference model. Here you can see this architectural reference model. Using this, it provides it gives the implementation standards for developers. That means that architectural reference model having some smart objects that will be deployed in the field. Okay, so that architectural reference model is generated by gathering the requirements. Okay, here you can see this gathering the requirements from stakeholders. We are going to gather the requirements from the stakeholders, and these requirements are validated by the stakeholders time to time. Okay, so this architectural reference model is generated by gathering the requirements from the stakeholder, and these requirements are validated by the stakeholders on the time basis. Okay, so work package framework also defines some use cases. Okay, it also defines some use cases for the application that will give the clear idea of the available functionality regarding the application. Okay, so circulation of these services worldwide and its impact over the business. Okay, so the impact of this application is on the business. Okay, then that maintenance strategy, management and coordination is there. Okay, so that maintenance strategy and the coordination of applications is there after the deployment. Okay, so this is the general work package framework. There is a protocol suite is there, different protocols are used for that. Okay, these are the this is the general work package framework. Okay, then here the next point is your ITU, that is International Telecommunication Union. ITU-T, that is Telecommunication Standardization Sector. So the mission is to ensure the efficient and timely production of the standards covering all the fields of telecommunication. Then the technical work, the deployment or the development of the recommendations of the International Telecommunication Union is managed by the study groups. Different study groups are there. There are currently 11 study groups are there. Here you can see that different study groups are there for the telecommunication union, that they are having their name, and there are some activities that are related to that IoT. Okay, for example, study group 2 is that is for operational aspects of service provision and telecommunication management. Okay, so the activities related to that IoT is numbering, naming, and addressing. So this is the different part from your syllabus. Okay, that is your International Telecommunication Union. Okay, so next part is like, or the next protocol is that is Internet Protocol for Smart Objects, that is IPSO. So this IPSO defines all IP approach for the standardization, for the IoT standardization. That IP defines a wide range of protocols that can be used to create highly scalable communication technology. Okay, so wide range of protocols suite is there. It also provides an open or lightweight or stable, pervasive, and manageable way to communicate between the applications and devices. So through the protocols, we are going to communicate with these applications. Okay, so the Internet Protocol for Smart Objects define some smart objects. So you know that what are the smart objects are there, like RFID tag, sensor, actuator, or any embedded device. Okay, like or any combination of these devices like RFID, sensor, actuator. Okay, so that embedded device like your small electrical devices that is built to serve a specific functionality, that is your embedded device. So this is the combination, or any smart device or any smart object having all these devices. Okay, that is your smart objects. So IPSO, that is Internet Protocol for Smart Objects, uses IP-based network protocols to communicate between the devices and the top layer applications. So like mobile IP. Mobile IP is one of the approach by Internet Engineering Task Force, that is IETF. So that IETF manages the movement of mobile devices across the your protocol like IPv4 and IPv6. Okay, so that IETF going to manage the movement of mobile devices by using the IPv6 and IPv4. Okay, this is all about your internet protocol for smart objects. And your next protocol suite is M2m and Wsn protocols. So as we have discussed in the last unit, that what is machine to machine. Okay, so M2m application and devices are getting popular nowadays. Okay, so more number of organizations are shifting their focus towards the M2M solutions. Okay, so that M2M protocol and WSN protocol standardization is now important for the growth of M2M and IoT industry. Okay, so that M2M protocol standardization, or that standardization efforts are there, like M2M standardization task force, that is MSTF, is going to coordinate the efforts of individual standards development organization, that is SDO for M2M application. So this M2M standard activities focuses on some points like data transport protocol standards. So this data transport protocol standard focuses on the standardization of machine to machine XML or JSON, that is JavaScript objects. Okay, and M2M device protocol standards. That it is the extension of OMA, like it can be collaborated and supported by the M2M protocol. Okay, so this standardization of the device management for the M2M. So this define a conceptual framework for machine to machine applications and specify a service layers that will enable application developers to create applications. Okay, so standardization of the device, as we are talking about the machine to machine communication. So the standardization of the device management, or the standardization of this device gateway systems and the configurations are these are the activities for the M2M protocol standardization. Okay, then there are some activities, as we have discussed about the activities like for the M2M standard activities, that includes it uses the JSON as a data transport format. Okay, it uses JSON and it resolves IP addressing issues for the devices regarding the IPv6. It uses the open REST based API. We have seen that what is REST based API for M2M application. Then remote management of devices behind a gateway or firewall, and it fixes the charging standards. Okay, so these are the activities that includes in the M2M standardization. So there are then your next standardization is your WSL protocol standardization. Okay, so there are number of standardization bodies in the WSN. So the that that standardization are like your many standard bodies like wireless sensor network for this WSN. So the concentration of this IEEE, or this IEEE focuses on the physical and MAC layers. Or if you have studied the OSI layers, you know that what are the physical and the MAC layers. Okay, so then the IETF, that is Internet Engineering Task Force, works on layers 3 and above. That you know that what are the layers are there. Okay, so it works on the layers 3 and the above layers. Okay, that means the standardization of layer 3 and the above, that is handled by the IETF. So IEEE 1452, it is the standard for set of smart transducer interfaces that will allow to develop network independently. Okay, so it can also be used for concentrating microprocessor, instrumentation systems, and the field networks. So there are different activities are there for the WSN standards. Okay, so that it covers the activities like here you can see this 1451.0 up to 2007. Okay, so that includes the standardization of interface function, communication protocols, common functions, okay, and TDS formats. And next activity is your 1451.1 1999. Okay, so these activities include the network capable application processor information model. Likewise, these are the different activities regarding this WSN standardization under 1451 activities. Okay, here you can see this 1451.0, point 1, point 2, point 3 up to point 7, like up to 2010. So there are different activities are there for the mixed mode communication protocols, wireless communication protocols are there, transducer to RFID is there. Okay, advanced system communication protocols are there under the WSN protocol standard. Okay, here you can see this up to 0 to 7. These are the standardization regarding the WSN. Okay, and then next format is your Scada and RFID protocols. Okay, so till now we have seen the IPSO web package format or the work package for framework. Then we have seen the IPSO, M2m protocol standardization activities, and WSN protocol standardization activities. Now we are going to see the Scada standardization activities. Okay, so Scada and the RFID are the enabling technologies. We have seen in the first unit that what are the enabling technologies that are there. So from that, Scada and RFID are the enabling technologies, or we can say that these are the two pillars of the IoT. Okay, so we know that they serve as one of the pillars from the IoT system. So now we will see what is Scada standardization activities. Okay, so we know that the IEEE created a standard specification. Okay, so the standard specification is your or it is called as a standard C37.1 TM. Okay, so this is the standard specification for SCADA and automation systems. Okay, see the standard specification for SCADA and automation system. Okay, so the uh, this is the standard specification for the SCADA, that is supervisory control and data acquisition. So we know that the IEEE standards that C37.1 SCADA architecture is well suited for, and it is well suited and applicable to the automation based industry. Okay, it is suited for automation based industry. Then uh, for a power system, okay, for a power system, it can be observed that the processing is distributed so that the functions and operations which can be performed by this control center is now performed by the IEDs, that is intelligent electronic devices. So they can be your IoT devices. Then then this SCADA is also standardized in the sense that how different vertical standards like specific industries technology standards are there that are going to interact with each other. So we know that how SCADA is working. Okay, so the processing is now distributed in this. Okay, and the functions that are going to be used to be done at the control center can be done by this intelligent electronic device, that is IED. Okay, that means your machine to machine. Okay, M2m between the devices. Okay, then this SCADA OPC, so that means object linking and embedding. Okay, OPC, which stands for object linking and embedding, that is OLE for process control standard specification developed by this IAITF, that is Industrial Automation Industry Task Force. Okay, so that develops the this OPC, that is object linking and embedding for process control. Okay, and then the the standard specifies the communication of real-time plant data between the control devices from the different manufacturers. So we have seen in the last unit that communication between the SCADA, how we are going to use the SCADA application for the communication, or by going to manage, or how to control the devices with software. Okay, so OPC was designed to provide a common bridge for Windows-based software applications and process control hardware. So we are going to control the hardware by the SCADA software. Okay, so OPC is designed to provide a common bridge for these Windows-based software applications to process this hardware or to control this hardware. Then next activities for the next part is your RFID standardization efforts. Okay, so as compared to other pillars of IoT, RFID data formats and the protocols are well defined by the EPC Global. Okay, so EPC means your electronic product code. So the RFID protocols and the data formats are relatively well defined by the EPC Global. Okay, so the standards for the contactless smart card communication is ISO EC. So uh, don't get confused regarding these standards. Okay, so there are different standards or different organizations are there for the every standardization. Okay, so there are different activities for each protocol. For like for M2m protocol, different standards are there, different activities are there. For WSN, different protocols are there, different standardization activities are there. Okay, and for this similarly, like for this Cada and RFID, different activities are there. Okay, so they are having different organizations are there, different industries are there. Okay, so as we have seen in the first unit, that is electronic product code EPC, we have seen in the first unit, that is EPC IC, that is electronic product code information service. Then we have seen also object name service. Okay, so these are the standardization in the RFID. In the very first unit, we have learned about the EPC and the uh, object name service. Okay, so these are the standardizations in the RFID. Remember that. Then physical markup language, that is PML, or it is a XML like language. Okay, PML is like a XML. So that defines its own tags to represent the data related to individual electronic product codes. That is IEPC. Okay, so PML is another language. It is like a XML. It's having its own, we can create our own tag to represent the data. So the at application level events test standard is there to create this EPC global. It also specifies an interface to write a business logic. So there are different standards are there. So one of the standard is being used in the contactless payment system, which uses RFID. Okay, so there are different standards are there for the uh, this protocol suits. Okay, so first we have seen that IoT architecture. So it is having the work package framework. ITUT is there, IPSO is there. There is Internet Protocol for smart objects. Then we have seen the M2m standardization, M2m protocol standardization. It's having the MSTF. Okay, then we have seen the WSN. It's having the standards like IEEE, which is developed by the IEEE 1451. So we are having the different activities from 14510 up to 27. Okay, so that all activities are controlled by this IETA. Then we have seen this SCADA standardization activities. So that SCADA includes the standards like uh, or this standard is developed by the IEEE, that is C37.1. Okay, and we are having the ISA, IATF. Okay, these are developed by the OPC. Then we are having, or we have seen the RFID, that RFID standardization activities. Okay, so in that we have seen that that EPC is there, EPC Global. That EPC Global develop the ISO or the IEC activities. Okay, then activities like, or the we have seen that the contactless smart card payment system that uses the ISO IEC 14443 and that ISO IEC. These are the standards, or these are the standardizations that allows communication up to 10 centimeters distance for the RFID. Okay, so there are different standardization are there, like for the contactless smart card payment system, we have seen the ISO IEC. Okay, ISO IEC. See the difference between the ISO IEC 14443 and the 15693. There is difference for between the that communication distance is there. For 143 is allowed for this 10 centimeters distance, and this 15693 is allowed up to 50 centimeters distance. Okay, so this is the difference between these two. So we have seen about this standardization activities. Okay, now we are going to continue with the issues with IoT standardization. So there are different issues are there with the IoT standardization. Okay, so we have seen that IoT standardization provides a solid way to develop IoT based systems, but there are some limits are there in the innovations or the productivity. Okay, like there are some challenges are there that are these challenges are faced by the standardizations, like many standards for the internet are not adequate, okay, for supporting the IoT efficiently. So that IoT didn't exist when protocols were designed and implemented. So there are no global validation for the standardization frameworks. Different organizations, forums, alliances, and groups are working on their own limited scope. Okay, so they are having their own standardization, their own limits. Okay, there is no centralization is there. Okay, so like we have seen the examples like EPC Global works on only that EPC Global works for only RFID. Okay, while that 3GPP work for only cellular network. So that it is found that two or more associations or groups are working on this standardization of same concept or technical area or same between their implementation. Okay, so ICT standardization is highly decentralized activity. So, so by considering these issues and challenges, that we are having challenge like how these activities of the heterogeneous channels can be coordinated with each other. So it is a challenge to develop a platform where various forums can collaborate to develop the standardization for IoT. So these are the different issues are there or different challenges are there. Like here you can see this standardization is like a double-edged sword. So it's critical to market development, but it may threaten innovations and inhibit change when standards are accepted by the market. Okay, so there are different issues are there, like different consortia, different forums, and different alliances having their different standardization. So as I said that different standardization is having different, or they are working with their scope, or they are having different limitations with their scope. Okay, so that standardization is highly decentralized activity. So we have to make that, or we are having a challenge to develop a platform where various forums or various organizations can collaborate to develop this standardization for IoT for decentralization. Okay, so for that there are different standards are there. Okay, so like solutions like we have to try and we have to standardize the ubiquitous middleware and XML based representation for data exchange. So there are different approaches are there for this uh, making this standardization, like W3C is there. Okay, like advance of or the organization for the advancement of structure information standards, OASIS standard is there. So we can, or they can provide the solutions, or we are having the XMLs to represent the data. Okay, so these are the issues under the development of, or the development of the IoT standardization. Okay, so till now we have seen the standardization activities for the machine to machine, WSN, Scada, and RFID. Okay, and we have seen the issues. What are the issues are there with the IoT standardization? Okay, now we are going to stop here. Okay, everybody understood? Don't get confused with the organizations or the activities between the that protocol suite. Okay, so we have, there are different protocols or different activities are there for each protocol suite. Like for M2m, there are different activities, different standardization activities are there. For WSN also different activities are there. Okay, for every pillar they are having different organizations or different activities are there. So have you understood? Yes. Have you understood all the activities? You are having any doubt? Anybody having any doubt with the standardization of protocols for the IoT? Yes, anybody having any doubt? Any
No,
doubt?
sir.
No, sir.
If any doubt, you can ask. Can I ask some questions? If everybody understood regarding this protocols, okay. So tell me the standards for the M2m protocol, M2m protocol standardization. Under this, which protocol standards we have seen for the data transfer protocol standards? It focuses on the, it focuses on which language or which standardization it focuses. Yes, anyone for M2m? Or tell me the issues with the IoT standardization. Issues with the IoT standardization. Anyone? Any issue? Have you observed that? What are the issues? What are the issues under the IoT standardization? Yes, anyone? Yes, Pallavi Popse. Unmute yourself.
Yes, sir.
Yes. Issues with IoT standardization. Tell me any one issue. Any issue. Any issue with the IoT standardization. What do you think? What we have to do, or what they are going to do for the centralization of the standards? Which language you have heard that regarding that they're having the similar what we can similar format like XML? कुठली language होती अशी? Hmm? Yes, anyone? We have seen one language, programming language like that is language is similar to XML.
Jason.
No, not JSON. We have seen that that JSON is
Python.
used for the M2m protocol standardization. Okay, we have seen another language which is similar to the XML. सर्वांचं लक्ष असतं ना लेक्चर मध्ये? Yes, we have seen one language that is having this same format, like we can uh, implement our own tags to represent the data.
XML.
That language is similar to XML, but what is the name of that language? Have you heard about the PML? Yes, we have seen that. Yes. In which topic we have seen that?
HTML, sir.
Not HTML. HTML and XML is different. In which topic we have seen that? In the RFID standardization activities, we have seen that PML language is there. What is the long form of PML? It is similar like XML. In that we can define our own tags to represent the data. Okay, that data related to individual electronic products codes. We have seen in the RFID standardization that PML is your physical markup language. Okay, different standardization activities are there for M2m, for WSN, for Scada, and for RFID. Different issues are there with this standardization. So what is the IPSO? What is the long form of IPSO? IPSO. Yes.
Internet Protocol for Smart Objects.
Internet protocol for
Smart Objects.
smart objects. Okay. So tell me something about that. IPSO defines some smart objects. What are that smart objects? Which are they? IPSO includes different smart objects like RFID tag is there, sensor, actuator, or some embedded devices. Okay. So I already provided this PPTs to you. Okay. So here you can see this work package framework is there. In that we have seen this architectural reference model, and how that architectural reference model, it contains the, or that reference model is generated by the, by gathering the requirements from the stakeholder, and the requirements are validated by the stakeholders on the time basis. Okay, we are having the use cases we are going to maintain, and we are going to control, or we are going to coordinate with the applications after the deployment. Okay, okay, we are going to stop here. Thank you.